Hello everyone, I am Homalata. I am from the Asian Disaster Preparedness Center. Hi everyone, welcome to session 2, Fundamentals of Nature-Based Solutions of the Hybrid course on Nature-Based Solutions for Disaster and Climate Resilience. Continuing from the discussion from session 1, we will look at the fundamental concepts of NBS and the various terminology used to gain a better insight on how NBS can be used effectively for disaster and climate resilience activities. In this session, we will look at the basic concepts and terminologies of NBS, starting from the various ecosystem services and the different NBS approaches, and look at the stakeholders involved in the process. Let's get started. Ecosystems are communities of living organisms in conjunction with non-living components of their environment interacting as a system. These components are linked together through nutrient cycle and energy flows. Ecosystems can be of any size, but usually encompass specific, limited spaces. Although it is sometimes difficult to see where one ecosystem ends and another begins. Key characteristics of ecosystems include structure. This includes the living plants, animals, and microorganisms and non-living components like air, water, and mineral soil that make up the environment. Function. Ecosystems are characterized by ecological processes such as photosynthesis, respiration, decomposition, and nutrient cycling. Complex interactions. Within an ecosystem, species interact with each other and the physical environment. These interactions can be complete, predatory, symbiotic, and mutualistic. Diversity. Biodiversity within ecosystems includes species, genetic, and ecosystem diversity. Dynamic nature. Ecosystems are dynamic entities. They are subject to period disturbances and are in the process of recovering from some past disturbance. Self-regulation. Ecosystems have the ability to self-regulate through feedback loops. Ecosystems are classified into various types, often based on the nature of predominant environments such as forest ecosystems, grassland ecosystem, desert ecosystems, aquatic ecosystem including marine and freshwater ecosystems, and man-made ecosystems like agricultural system, agroecosystems. Each type of ecosystem has a distinct characteristic and species adapted to its specific environment. The health and functionality of ecosystems are critical for provision of ecosystem services upon which all life, including human, depends. Ecosystem services are the many and varied benefits and ecosystems provide to humans. These services are essential for survival and well-being of humanity and are generally categorized into four main types. Ecosystem services are integral to human well-being, and their degradation can have significant adverse effects on human health and prosperity. The concept is crucial in environment and ecological economics, conservation and sustainability strategies, land management, policy making, as it provides a framework to help recognize the value of nature's contribution to humanity. From this picture, what ecosystem services are being provided here? If you mentioned food provision, fish and other freshwater organisms, regulation, flood control, support, like nutrient cycling and recreation, then you are on the right track. Ecosystem services can be classified into four types of services. Provisioning services. These products are obtained from ecosystems such as food, fresh water, wood and fiber, genetic resources, and medicinal resources. They are the most tangible benefits that humans derive directly from ecosystems. Regulating services. These services include benefits obtained from the regulation of ecosystem processes, such as climate regulation, disease control, water purification, pollination, carbon storage, and flood mitigation. Regulation services help to maintain the balance of the environment that supports life. Cultural services. Ecosystems provide cultural or non-material benefits that people obtain through recreation, tourism, spiritual enrichment, cognitive development, reflection, and aesthetic experiences. This includes the inspiration we derive from nature, the spiritual significance of certain landscapes, and the community value of parks. Supporting services. These services are necessary for the production of all other ecosystem services, including soil formation, photosynthesis, nutrient cycling, water cycling, and the provision of habitat. They underpin the functioning of ecosystem and the production of mentioned services by maintaining biodiversity and the production of ecosystem goods. The loss of ecosystem services is a significant risk to the future prosperity and stability of human society. Recognizing their value is crucial for sustainable development and for devising strategies to conserve and restore natural habitats and the services they provide. The value of ecosystem services is immense and multifaceted, encompassing economic, environmental, social, and cultural dimensions. Quantifying this value can be challenging, but essential for informed decision making and sustainable resource management. Here are various aspects of the value that ecosystem services provide. Economic value. Ecosystem services contribute directly and indirectly to the economy. Provisioning services such as water, food, timber, and fiber are the basis of industries like agriculture, fisheries, and forestry. Regulating pollination and water purification services are critical for sustaining these industries. By estimating the cost of replacing these services with man-made alternatives, we can begin to quantify their economic value. Social value. Ecosystem services are crucial for social welfare and community development. They support livelihoods, especially for rural and indigenous communities that directly rely on natural resources. Cultural services provide a sense of place and identity, which is important for social cohesion and mental health. Environmental value. Ecosystems maintain biodiversity and genetic diversity, which are vital for the resilience of the environment to adapt to changes and disturbances. They help regulate climate, air quality, and disease vectors, which are essential for the stability and sustainability of the planet's life support systems. Cultural value. Natural landscapes are deeply interwoven with human culture and history. They serve as inspiration for art, folklore, and spiritual experiences and are integral to education and recreation. The cultural significance of ecosystem is invaluable and often irreplaceable. Health value. By providing clean air, water, safe food, and opportunities for recreation and stress relief, ecosystem services have a profound impact on physical and mental health. Intrinsic value. Beyond the utilitarian benefits of human ecosystem have intrinsic value. Many argue that nature has value in its own right, independent of human needs or perceptions. Regulatory value. Ecosystems contribute regulatory benefits that help mitigate natural disasters, such as flood control by wetland or storm surge protection by coral reefs. The cost savings for disaster relief and infrastructure repair can be considerable. Support services value. The fundamental processes like soil formation, nutrient cycling, primary production are building blocks upon which other services depend. While these services do not have a direct market value, their contribution is essential for the provision of all other ecosystem services. These values can be captured through monetary, quantitative, or qualitative approach to demonstrate the importance of ecosystem services. Given ecosystem services, vast array of benefits, their degradation or loss can have significant economic and societal cost. Recognizing and integrating the value of ecosystem services into policy making, planning, and development is crucial for the sustainable use of our natural resources and the well-being of the current and future generations. Nature-based solutions refer to sustainable management and use of nature for tackling socio-environmental challenges. This approach effectively addresses issues like climate change, food and water security, human health, and disaster risk. NBS are grounded in the area that nature can provide valuable services that help societies to achieve resilience and sustainable development. NBS are not a panacea and need to be applied carefully, considering the socio-ecological context. However, when implemented well, NBS can be a powerful tool for building sustainable future. Key aspects of NBS include conservation, restoration, and sustainable management. This involves protecting existing ecosystems, restoring degraded ones, and managing both natural and modified ecosystems to balance people's and nature's needs. Ecosystem services. NBS relies on and enhances ecosystem services such as clean water, air, fertile soil, and pollination. Biodiversity. They contribute to biodiversity conservation, which is fundamental for ecosystem resilience and the continued provision of ecosystem services. Climate adaptation and mitigation. NBS can be instrumental in adapting to climate impacts, like absorbing excess flood water or providing shade in urban areas, and mitigating climate change through carbon sequestration in forests and wetlands. Disaster risk reduction. They can help reduce the risk and impacts of disasters, such as using wetlands to buffer storm surges or mangrove restoration to protect coastlines from tsunamis. Social and economic benefits. NBS often provides livelihood opportunities and economic benefits, promoting sustainable development in local communities. Cost-effective and multifunctionality. NBS can be more cost-effective than traditional engineered solutions, often delivering multiple benefits simultaneously. Nature-based solutions is an umbrella term. You might have heard other technical terms such as ecological restoration, ecological engineering, forest landscape restoration, ecosystem-based adaptation, ecosystem-based mitigation, climate adaptation services, ecosystem-based DRR, natural infrastructure, green infrastructure, ecosystem-based management, area-based conservation are part of NBS. Here are some more details of the various approaches under NBS. Ecosystem approach is the primary framework of NBS implementation. The ecosystem approach is a strategy for the integrated management of land, water, and living resources that promotes conservation and sustainable use in an equitable way. It is grounded in the principle that humans with the cultural diversity are an integral component of many ecosystems. This approach is recognized and widely adopted in environmental and conservation strategies, including those under the Convention on Biological Diversity. Forest landscape restoration. Forest landscape restoration is a process that aims to regain ecological integrity and enhance human well-being in deforested or degraded forest landscapes. It is not just about planting trees or natural forest regeneration. Forest landscape restoration involves a holistic approach that integrates forestry, agriculture, conservation, and other land uses to restore the functionality and productivity of landscapes. Ecosystem-based adaptation. Ecosystem-based adaptation is a strategy for adapting to the adverse effects of climate change by harnessing the natural capacity of ecosystems. It involves the use and conservation of biodiversity and ecosystem services as a part of an overall adaptation strategy to help people to adapt to the adverse effects of climate change. Ecological restoration is the process of assisting the recovery and management of an ecosystem that has been degraded, damaged, or destroyed. This scientific discipline and practice aims to restore the structure, function, and diversity of disturbed or impaired ecosystem to a condition as similar as possible to that which existed before the disturbance. Protected areas are used to conserve nature and to provide a range of ecosystem services that do not conflict with nature conservation. Examples of protected areas are Yellowstone National Park in the US, the first national park in the world, the Great Barrier Reef in Australia, and Sundarbans National Park in India, that is well known for its mangrove forest and a large population of Bengal tigers. Ecological engineering, also known as environmental engineering, is an interdisciplinary field that focuses on design, monitoring, and construction of ecosystems. The primary goal of ecological engineering is to develop sustainable solutions that integrate human society with its natural environment for the benefit of both. It involves the application of engineering principles to the management and restoration of ecological systems. Through this diagram, we can have a better understanding of the interlinkages among the different approaches under the nature-based solutions umbrella. Nature-based solutions are increasingly acknowledged as vital and efficient methods for achieving sustainable development. These approaches involve the protection, maintenance, and revitalization of natural or altered ecosystems to tackle societal issues with which concurrently delivering benefits for human well-being and biodiversity. NBS are instrumental in preserving biodiversity through the upkeep of restoration and natural habitats, a critical factor for maintaining ecological equilibrium and the survival of diverse species. In addressing climate change, NBS are pivotal. They aid in carbon sequestration, such as through reforestation efforts, and serve as natural defenses against climate-related impacts, exemplified by mangroves shielding coastlines from storm surges. NBS are key in sustaining crucial ecosystem services, including the provision of clean water, air purification, pollination, and soil fertility, all foundational for human survival and health. Integrating natural components into both urban and rural setting, NBS fosters sustainable economic growth through avenues like ecotourism, responsible forestry, and agriculture. Natural settings contribute significantly to physical and mental health. Urban green spaces, for instance, offer recreational and relaxation areas, enhancing overall well-being. NBS bolster community resilience against environmental hazards and disaster. For example, preserving natural floodplains and forested watersheds can mitigate flooding risk and impacts. Long-term NBS proved to be more economical compared to conventional engineering methods, especially when the extensive range of the benefits is considered. Local communities often find themselves involved in and benefiting from NBS. These solutions support livelihoods such as through sustainable resource usage and empower communities to oversee their natural resources. In urban areas, NBS play a crucial role in fostering sustainable, livable cities. This is achieved through initiatives like green roofing, urban forestry, and construction of wetlands for wastewater treatment. NBS are effective in the sustainable management of water resources, seen in actions like wetland restoration, which aids in water filtration and flood control. Promoting sustainable agriculture practices essential for food security is another facet of NBS. Agroforestry is a prime example, combining trees with agricultural crops to boost biodiversity and soil health. To sum up, NBS are not just beneficial but indispensable for sustainable development. They present a comprehensive approach that harmonizes environmental, economic, and social considerations, contributing significantly towards meeting the United Nations Sustainable Development Goals. However, it is crucial to apply these solutions thoughtfully, ensuring they are strategically planned and managed to circumvent any unintended adverse effects. Ecosystem adaptation and eco-disaster risk reduction are gaining recognition as superior methods for addressing environmental and societal challenges, especially in the realms of climate change and disaster management. These methods are often more financially viable over the long term than conventional engineering approaches. For instance, natural formations like wetlands and mangroves serve as cost-effective alternatives for flood water defense and coastal protection, with the added advantage of natural self-repair and regeneration. These ecosystem-centered strategies for multiple simultaneous benefits, restoring a forest, for example, not only aids in carbon capture but also bolsters biodiversity, solidifies soils, and purifies water. Ecosystem DRR tactics such as mangrove restoration simultaneously safeguards coastlines, creates fish habitats, enhances water quality, and bolsters local fisheries and community livelihoods. Both ecosystem adaptation and eco-DRR significantly increases the resilience of natural ecosystems and human communities against the impact of climate change. Robust ecosystems have a great capacity to endure and recover from extreme weather events, thereby continuously safeguarding and serving communities. Rooted in sustainable resources use and management, these approaches ensure the ongoing availability of ecosystem services for the present and future generations. Incorporating local communities in the development and execution of these strategies leads to more enduring and culturally attuned solutions. This involvement fosters environmental stewardships and equips communities with the skills to manage their resources effectively. Focusing on the health and integrity of ecosystems, these methods are pivotal in conserving biodiversity, habitat protection, and restoration play a key role in preserving species and genetic diversity essential for the proper functioning of ecosystems. Adaptable to shifting environmental conditions and receptive to new information, these ecosystem-based strategies are especially apt for navigating the uncertainties for climate change. Moreover, thriving ecosystems are instrumental in enhancing human health and well-being. Urban green spaces, for instance, can better air quality and offer recreational zones, thereby improving mental and physical health. Incorporating traditional ecological knowledge, these approaches provide profound insights into sustainable resources and natural disaster mitigation, drawing on long-standing observations and experiences. Applicable across a wide spectrum of scales, from local community projects to national and global policies, ecosystem-based methods are versatile and relevant in various contexts. Ecosystem adaptation and eco-DRR are comprehensive, sustainable, and practical approaches for environmental management and disaster risk reduction. They utilize the advantages of healthy ecosystems to tackle current challenges while fostering biodiversity, sustainability, and community resilience.